For decades, humanity searched the stars hoping to find another world like Earth. A planet with oceans, clouds, and the right conditions for life to exist. But what if the greatest discovery is not finding a planet that could support life, but finding one that may already be alive? Far beyond our solar system, more than 120 light-years away, a strange world called K218b circles a dim red dwarf star in the habitable zone, the region where temperatures may allow liquid water to exist. At first glance, it seemed like another exciting exoplanet discovery. But the deeper scientists looked into its atmosphere, the stranger the story became. K218b is not a smaller copy of Earth. It is far larger, nearly 8 times the mass of our planet and more than twice its size. Astronomers classify it as a sub-Neptune, a type of planet unlike anything in our own solar system. Instead of rocky continents and open skies, this world may be covered by a massive global ocean hidden beneath a thick hydrogen-rich atmosphere. Even so, the planet sits at just the right distance from its star to keep scientists fascinated. Observations revealed traces of water vapor, methane, and carbon dioxide in its atmosphere. These molecules alone are not proof of life, but together they create a picture of a world rich in chemistry and possibly capable of supporting biological activity. Then came the discovery that changed everything. Using the powerful instruments aboard the James Webb Space Telescope, scientists detected possible signs of a molecule called dimethyl sulfide, or DMS. On Earth, DMS is strongly linked to living organisms, especially microscopic marine life like plankton. That does not mean alien life has been confirmed. The signal remains uncertain, and researchers continue debating whether non-biological processes could also produce the molecule. But the idea alone transformed K218b from an interesting planet into something much more unsettling. For the first time, humanity was not just looking at a world that might be habitable. We were looking at a world whose atmosphere could already contain the chemical fingerprints of life. If life exists there, it is probably not intelligent. There are likely no cities, no spacecraft, and no civilizations calling into space. Any biology on K218b would most likely be microscopic, ancient, and ocean-based. Yet even that possibility would change everything humanity believes about the universe. Because if simple life can emerge on a strange ocean world wrapped in hydrogen under the light of a red dwarf star, then biology may not be rare at all. Life may not require perfect Earth-like conditions. It may arise in environments far stranger than we ever imagined. That realization carries a powerful emotional weight. For years, people imagined habitable planets as empty frontiers waiting to be explored someday. But K218b challenges that fantasy. If the signs are real, then this world is not empty. It may already belong to its own ecosystem, however tiny and invisible that ecosystem may be. Suddenly, the universe feels different. Instead of silent and lifeless, it begins to feel occupied. Not by advanced civilizations necessarily, but by countless biological stories unfolding across distant worlds completely independent of humanity. What makes this even more extraordinary is that K218b may only be the beginning. The James Webb Space Telescope continues studying more exoplanets, analyzing their atmospheres in unprecedented detail. Again and again, scientists are finding planets with intriguing chemistry, thick atmospheres, clouds, and possible signs of habitability. Some turn out to be too hot. Others lose their atmospheres or experience extreme radiation. But the deeper pattern is becoming harder to ignore. The ingredients for life appear throughout the galaxy far more often than we once expected. And that possibility changes the meaning of discovery itself. The greatest shock may not be learning that life exists somewhere else. The real shock may be realizing that life was never rare to begin with. There is something deeply eerie about the idea that our first serious evidence of alien biology may arrive not through radio signals or giant structures in space, but through tiny chemical traces hidden in the atmosphere of a distant world. No message. No voice. Just a faint atmospheric whisper crossing more than 100 light-years of darkness. That is what makes K218b so unforgettable. It suggests that the universe may not announce life dramatically. It may reveal it quietly through chemistry, through oceans hidden beneath clouds, through gases drifting through alien skies. And if that is true, then humanity is not standing at the beginning of life in the cosmos. The deeper scientists investigate K218b, the more unsettling the implications become. Because this discovery is not only about one distant planet. It is about the possibility that the galaxy itself may already be filled with living worlds hidden behind clouds, oceans, and atmospheres we are only now learning how to read. For most of human history, Earth appeared unique. Every ocean, every forest, every living creature seemed to reinforce the comforting belief that life here was a rare cosmic accident. Even after thousands of exoplanets were discovered, many still assumed that truly habitable worlds would be incredibly uncommon. But the universe keeps refusing to stay simple. The James Webb Space Telescope was designed to peer deeper into space than any observatory before it, capable of analyzing the atmospheres of distant planets by studying how starlight passes through them. And what it is revealing is a cosmos overflowing with complexity. Some worlds are scorched by radiation. Others are frozen in darkness. Some are giant gas planets with storms larger than entire solar systems. Yet mixed among them are planets with water vapor, carbon chemistry, thick atmospheres, and conditions that challenge the old assumption that Earth was extraordinarily special. K218b stands at the center of that growing mystery because it may represent an entirely new category of habitable environment. Not an Earth clone, but something stranger. A vast ocean planet beneath a hydrogen-rich sky where exotic chemistry may allow biology to survive in forms humanity has never encountered. And that possibility forces scientists to confront a disturbing idea. What if life does not need perfect conditions? What if biology is incredibly adaptable? What if it emerges anywhere energy, water, and chemistry can interact long enough? If that is true, then life may not be scattered sparsely across the galaxy. It may be everywhere. Hidden beneath icy crusts. Floating in thick atmospheres. Drifting through alien oceans under dark red suns. That changes the emotional meaning of space itself. The night sky stops feeling empty and starts feeling alive in ways we cannot directly see. And perhaps the strangest part is how quiet it all is. There are no dramatic invasions. No giant signals echoing through the galaxy. No obvious evidence of advanced civilizations announcing themselves across space. Instead, the first real hints of alien biology may arrive through spectral lines, faint molecular signatures buried inside light collected by telescopes orbiting far above Earth. Tiny clues. Tiny whispers. Yet those whispers may carry one of the biggest revelations in human history. Because once scientists seriously entertain the possibility that a distant atmosphere contains a molecule associated with life, the entire cosmic conversation changes forever. Suddenly, every new exoplanet becomes more than a distant object. Each one becomes a possible biological world with its own evolutionary history unfolding far beyond human reach. Some researchers remain cautious about K218b, and for good reason. The data is still incomplete. The DMS signal could disappear with future observations. Unknown chemical reactions may explain everything without requiring biology at all. Science moves carefully because extraordinary claims demand extraordinary evidence. But even uncertainty now feels revolutionary. A decade ago, humanity barely knew how to study exoplanet atmospheres in detail. Today, we are debating whether traces of alien biology may already have appeared in the data. That alone marks a turning point in human history. And the future may become even more astonishing. New generations of telescopes are already being planned, machines far more powerful than the James Webb Space Telescope. They may eventually analyze hundreds of nearby worlds, searching for atmospheric combinations impossible to explain without life. Oxygen, methane, water vapor, carbon chemistry. Patterns that, together, may reveal entire living ecosystems across the galaxy. If that moment comes, humanity may be forced to accept something profoundly humbling. Earth may not be the center of biology and the universe. It may simply be one example among countless living worlds scattered through cosmic darkness. And perhaps that is the true meaning of discoveries like K218b. Not proof that aliens are visiting Earth. Not proof of giant civilizations. But proof that life itself may be woven into the fabric of the cosmos far more deeply than humanity ever imagined.